You guys want more cables? Yes. Hello, sorry, I was just running around getting some cables, but we don't need them actually. So that was just a fun thing to do. So hello everyone, sorry I'm late. My name's Richard. We'll be together for 1927.
That's the name written on the shirt.
That is my name written on the shirt. And if you can decode it, you'll get it. So, oh, hello. Hi. Oh, there are other people here I know. Is there anyone here who I've taught before? No, just the one. Do you guys find this room very hot and stuffy? Yes. Yes, it's unpleasant, isn't it? I've turned the air conditioning on. Who was in here before? Does anyone know?
Banking, finance.
Banking and finance. Let's see if it cools down. If it doesn't, we'll start fooling around with the doors. Just give me 1 second to collect my thought. I've literally run through the building stealing everyone's firewire cable. I've knocked at the door and said, firewire cable? Yes. Boom, out of the way. Thanks. So, could everyone bring a firewire cable tomorrow? That would be a great help. Thank you. All right, give me 1 second to log in. No serial. Well, no, bring it in. Who knows? We never know when we'll need one. Give me 1 second. All right, I think it's turning on. It appears to be turning on. Ah, fantastic, we're in. So let's start with our course homepage. As you'll get to type this shh, 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 shh. Now guys, come on, I've done my part. I'm here on time and organised. The least you could do is just, you know, let's go. Tilde CS1927. Let's go, and this is the course. And has anyone already checked out this page? Yes, some of you have. Well done. If you haven't, make sure you go. Basically, the normal CSC beginning, www.csc.unsw.edu.au/tilde1927. So welcome to 1927. With layer upon layer of protection. Just to make sure there's no accidental learning going on. Let's make that bigger. That's as big as we can get. There we go. All right. Now, who can read that at the back? Is that fine? It's quite a bright room, but the slide's still bright enough. Is it cooling down a bit, or is it still hot? Too bright. It's still too bright. Let me see what we can do. How's that? Much better. So welcome everyone. It'll take me a second to calm down because when things go wrong at the beginning, you know, you get a bit flustered. And you'll probably find this yourselves when you're programming or when you're in an exam, that sometimes things do go wrong. And if you're all like me, once things go wrong, you put off your stride. So what's the best thing to do? For example, if you're trying to work on your program and something goes wrong and you're stressed and cross, what's the best thing to do? Work on something else. Take a break. What's your name? Hossam? Sam. Just Sam. Yep, Sam's right. So basically, that's my advice. When things don't go well, don't freak out, but calmly switch to something else. In fact, my overall theory about computing is that although we initially approach computing as an exercise in syntax, in learning how a language works, or in understanding how to use a particular operating system, the computing is really more a mental discipline, I think. And being a successful programmer is really a state of mind. And it's a state of mind that involves sort of calmness and focus. And when things go wrong, as things always do go wrong, we don't give up and we don't freak out. We carefully try and try again. And hopefully that's a message you've already got in 1917. In 1927, we want to hone that message down a bit. When things go wrong or you don't know what to do, don't just mindlessly try and try again. In this course, we're going to suggest that you should adopt an attitude of systematically try again. And we're going to try and now introduce some sort of methodology and systematization of the process of writing programs and dealing with problems. You've all come from one, well, actually that's not strictly true. You don't have to have come from Comp 1917. Who here's come from another course? Who here hasn't done 1917? Fantastic. Okay, so you've all done 1917. I've been checking out 1917 as it was running last semester. I really like Maury, so you're very lucky to have him. And I was enjoying watching what you're doing. And some tutors mailed me, some of your tutors mailed me with pride at some of the assignments that you guys did, especially towards the end. And I was just checking out the projects again just before I came here. And let me just show you some of the projects that you guys did last semester. Made me very happy. Now, this, I've only previously looked at the ones that people sent me, and this morning I was going through looking at them all. They're very slick. Oh, I mean, this one's got a screen size problem. But that's a display. It's on 140%. That's what you're supposed to be getting in this course. That's the speed at which I'll be talking and the expected mark to pass the course. Yeah. You can't see it 140%? Well, everyone, you'll have to get glasses that are 40% bigger to see. So this is awesomely good, but you were struck with the constraints of the game that it wasn't a very visual game. But this was just very impressive. Did anyone write one which involved photographs? I'm sure I saw one with photographs around the uni, but I haven't seen it flipping through today. Is that one of the ones here? Which one is it? Who's Ricky? Wave at me, whoever Ricky is.
One with numbers and letters and dash in the middle, you know? That one.
Yeah, well, who's Ricky? Ricky, wave at me. Ricky's not waving. Oh, Ricky's further across. Oh, there. You're Ricky? Hello, Ricky. It's an excellent name. What tute were you in last semester?
Dave, Colin.
What day was your tutorial? Thursday at 9 o'clock?
No.
Oh, that's an H, isn't it? Thursday, oh, there's only one. There we are. Is this it? Is this yours? No.
I don't think it's up there.
It's not up there. Oh. Is this it? Is this yours? No, okay. Oh, all right. Well, that's an aborted attempt. No, show it to me. I'll put it up next. Just tell me at the end. I'll put it up next lecture, next pair of lectures on Thursday. But I was very impressed with your guys' design ability, and the games were fun, and I enjoyed looking at them, and it was very good. Here's my hope as to what you've already Now, that's spectacular. Does anyone know Microsoft's phone number?
Yep. 13772.
Yeah, look, I'm using Internet Explorer. Yeah, you wouldn't believe it. I can't believe I'm using Internet Explorer. Let's just fix that up.
Send the error.
No. No, secondary market. No. Let's do this all in Firefox. Let's go. Yes, no, I'll have to start again at the beginning. I am sorry about that. Hello, everyone. Welcome to 1927. Okay, and make it, what was that, 140? Oh, please turn your mobile phones off, if you have a mobile phone. Yes, Thurston, we have a problem. Don't worry, it's just rebooting. Everything's okay. So 1917, here's what I expect you to get out of 1917, and here's what I hope you have. No, here's what I hope you've got out of 1917, and what I'm expecting you to come to me with. I'm assuming by now you can program in C. I'm assuming you can deal with loops, and nested loops, and one-dimensional arrays, and two-dimensional arrays.
27-dimensional arrays?
Yeah, arrays to any dimension. I'm assuming that you can, you understand pointers and memory allocation, that you understand how to use malloc, that you can construct and traverse a linked list, that you can construct and traverse a tree, a binary tree. I'm expecting that if I asked you to create a ring, which is a list where the beginning attaches to the end, that you'd be able to have a fair whack at doing it, even if you hadn't already seen it. In other words, I'm assuming you have a basic competency in C, and in this course we'll be using C rather than teaching C. If you are not up to speed with C, if your C is not exactly spot on, then we'll be running a small prac exam next week in the lab, which will give you an indication as to the level we expect. If you don't manage to do the prac exam, or if you do manage to do the prac exam but still feel there are weaknesses in your C, can I encourage you as quickly as possible to brush them up in your own time, because we won't be spending any time on them in this course. If you're worried about your programming ability, please speak to your tutor, and I'm sure they'll give you extra programming exercises, and we might even run some remedial classes for people that need an extra brush up or reminder. But just be aware that from now on, I'm assuming everyone can program, and we're going to do things with C rather than talking about C itself. That's called a precondition. Does everyone understand how preconditions work? Let me show you on the board. I want you to think of 1927 as being like a black box. Give you some light. Oh, I don't know how to turn that light on. What do you think? It's not plugged in? No one's used this in hundreds of years. There we go. So, yes. So 1927 I like to think of as a function. And it takes in some students. And it puts out some students. So it's a function from students to students. If you enter this course already knowing how to program, my job is to put you out the other end of the course as computer scientists. So what do we call this thing that I said then, if you already know how to program? What's the jargon word for that? It's a precondition. Something that must be satisfied. Have you learnt this already in 1917? Yes? No? Yes? No? No? No. Okay. Now you've learnt it in 1927. The things that you have to satisfy before starting are called the preconditions. The qualities that you can rely on after finishing are called postconditions. And a function is something that goes from preconditions to postconditions. In C, when you write a function that has preconditions, how do we deal with that? If you're writing a function to divide a number by 0. Oh. Excellent. You're writing a function to divide take two numbers in, divide one by the other. And the precondition is that the number that goes on the bottom is not 0. How do you write that function? And your output is the answer. Assert, yeah, that's right. If you used an if statement, you'd be using the logic of your program. Your program would be doing overhead, and the actual flow of your function would be trying to deal with the problem of when an assertion's not met. And it's not your program's problem to deal with input which doesn't meet the criteria. So the idea is that we can assume the input coming in is completely correct. We don't have to put program and logic in to deal with it not being correct. Nonetheless, being paranoid programmers, we know that sometimes it won't be correct. So the standard way of dealing with that is we put an assert at the beginning of your program that asserts the preconditions. So you would assert I can never remember which is on the bottom. Is that the divisor or the dividend? Or the dividend? The denominator. That'll work for integers. We might have to do something a bit fancier for floating point numbers. Can you read that? No, it's actually quite glary. No? Yeah, we get reflected light on it. There we are, they're my shoes. Okay, so in this course, if you were designing a course, how would you ensure the preconditions are met? Prerequisites, yeah, they specify the preconditions. But you can be sure that somehow, as a programmer, you can be sure that sometimes your function is going to be called with data that doesn't satisfy the preconditions. And you've got an assert at the beginning to do it. And what am I putting in that's my equivalent of an assert? A prac exam. Yeah. Now, if you don't pass the prac exam, I don't mind. It's only like worth a lab mark or something. It's not irrelevant. But the reason is it's to flag that you're not meeting the preconditions and to give you an indication to go on. This is a bit depressing, isn't it? Let's talk about something more interesting than that. 40 years ago, almost to the day, back in my day, Neil Armstrong landed on the moon. And he said, one small step for man, one giant leap for mankind, which is a pretty cool thing to say. And actually I heard an interviewer interviewing him recently. Recently I heard an interviewer interviewing him. The interview actually happened 20 years ago. And the interviewer said, before you went up, I asked you at the press conference, what were you going to say when you landed on the moon? Did you have anything thought out? And you looked at me blankly and said, nah. And yet when you landed, you had this beautiful thing to say. When did it come to you? When did this idea, when did you suddenly realize what you were going to say? And Neil Armstrong said, prevaricate. He didn't really answer. But I was struck by that. I thought, wow, if he could come up with such a neat quote in such a short period of time, what a profound person. And then I thought, probably not, because he was doing a profound thing, and the phrase might have even suggested itself to him. So let's look at this. One small step for man. Literally, what he was doing was a small step. What was the giant leap? The achievement, space. In what sense, if you were trying to explain it, I've got a 5-year-old girl. If I was trying to explain to her, Neil Armstrong said this. He said, one small step for man, one giant leap for mankind. She'd go, well, she'd probably say, she's very literal, did he leap? What? I don't understand. How would I explain to her? What would I say? On the moon, gravity's lower, a small step could turn into a leap? Yeah, I could. I could say that. So what's the, I mean, you know, just can someone articulate it? Yeah, what its meaning is, essentially. What the act itself is trivial, the meaning of the act is quite profound. Because he knew that once we'd done that, within 10 or 20 years, we'd have colonies on the moon. We'd be in Mars. We'd be, you know, truly extraterrestrial. It was a very exciting beginning. I'd like you to think of 1917 as being looking at the small steps. 1917 is about what we do, the mechanics of a program, writing the program. But what's really interesting, I think, in computing, what's interesting for me, is what it means when we write a program. Thinking about a program in a more profound way. You need to be able to write them to get to this state. You need to be able to take that step for it to be a giant leap. But gee, if you were just talking about small steps all the time, life wouldn't be that much fun. So let's sort of have that as a sort of a motto for the course, that this course in a way is about meaning. Now, I have 3 letters up here. That's just my sort of mnemonic for remembering the central sort of breakdown of the course. PAP. In computing, we have a problem. We solve the problem with an algorithm. We implement the algorithm and produce a program. We run the program and we get a problem. We get a process. So this is a static thing. This is C source code. This is the code in motion. It's called the process. So this is computing. when you're learning programming, like I'll use 1917 over and over again. I hope you won't get sick of me saying in 1917. I'm just trying to contrast what we're doing with what we've been doing before. In 1917, you've been interested in which step or steps? I think you will generally have been given an algorithm. Not always, but generally given an algorithm, and you will produce a program to implement that algorithm. And sometimes for fun, you might have had to think of your own algorithms. So hopefully, you are now very competent at this step in the process. Given an algorithm, you can render it into C. And hopefully also in 1917, you have learned what a program looks like when it's running. Hopefully you now understand the structure and organization of memory. You understand a little bit about the CPU. You understand what's happening step by step inside the computer. So when you get a stack overflow, hopefully you know what that means. When you get a segment fault, hopefully you know what that means. What happens if you get a segment fault? What's probably happened? It will crash, but what does it mean? You're accessing some memory you shouldn't be accessing. How could your program access memory it shouldn't be accessing?
You've accidentally forgotten to have an engine, like if you're iterating through like a list or something, you've forgotten to...
Yeah, that's right. If you're following pointers, you're doing some sort of pointer chasing thing, is that what you mean?
Yeah, like pointer.
Yeah. If you're following pointers, maybe moving along a linked list, and one of your pointers points off into outer space, it's just got random rubbish in it. You don't terminate properly with a null, and you jump to that spot and try and read from it, and it's an area of memory, a segment that the computer's not expecting you to be able to read from. It's not in the data segment. Oh yeah, in an array the same thing can happen too. Yeah. In an array, the array might be located near the end of a data segment. Oh heck, it could be anywhere, couldn't it? Let's suppose it's even at the beginning of a data segment and you've got a while loop that's scanning through the array and you don't terminate the while loop properly, so you read beyond the bounds of the array. If you keep reading, you'll eventually start reading into another segment and you'll get a seg fault. Does it become a problem when you hit the seg fault? When is the actual problem if we're looking at an array? This is just quick super revision. We're reading through an array. Read. I hit the end of the array, I keep reading. Read. When's it a problem? Read. I now hit the end of the segment. I'm in the next segment. Now I get a seg fault. When did it become a problem? What's that? As soon as I pass the boundary, the end of the array. Yeah. What's the problem with reading or writing beyond the bounds of an array? You could attack other variables and damage the variables in operating of your program. Yeah, that's one bad thing that could happen. What's another even more bad thing that might happen?
Set off a chain reaction.
You could set off a chain reaction. You could, like, cause some sort of meltdown or something like that.
Like so one variable goes off and then it actually checks that variable.
Yes. By changing the value of one variable, it might change it in such a way that the program keeps soldiering on regardless, but now one of the variables is skew with, and that might cause it to muck up another variable. Maybe the first variable it mucked up was the size of another array, and now your other array, yes?
Opens up huge security holes.
Thank you, security's the problem. Yeah. Every time you turn on Windows and it starts saying Microsoft apologizes for a little while, what are they apologizing for?
Nothing.
While it's downloading? They're apologizing for their programmers writing programs which read or wrote beyond the bounds of an array. And hopefully in 1917 you were chastised about doing that and driven to not do that, is that right? It's my personal bugbear because I teach security as well, and there is no fault, there's no excuse for most of the security vulnerabilities that common software has these days. It's simply because people are writing and reading beyond the ends of the arrays. So one thing, if you really want to annoy me ever, is just read or write beyond the end of an array. It'll just, every time you do that, somewhere, a fairy dies. So, please don't do that. Okay, so hopefully in 1917 you've done these two parts, the P and the P. And you've looked, well, the parts are actually moving. So you've moved from A to P. Now in this course, we're in the other half of the world. We'll be looking a bit at problems, and we'll be looking a bit at algorithms. We'll be talking a bit about moving from problems to algorithms and the relationship between them. In the course that follows this, 2911, that's all they talk about. This arrow here. 2911 is all about, given a problem, How do I come up with an appropriate algorithm? And by algorithm, I actually mean algorithm and data structure. They sort of go together normally. Okay, so in this course, just to give us a context, we're looking at problems and we're looking at algorithms. Now, I've got some admin stuff to do, because we always do that at the start of a course, don't we? Except we're so hot and stuffy and we got here late and we're all stressed that I think rather than doing the admin stuff, because how a course normally goes, as you know, is the first lecture you just talk about admin all the time. And then for most of the rest of the course you learn stuff. And then for the last week or two the lecturer just talks about movies. I thought, why don't we just run it backwards? So let's just talk about movies. Because I happen to have some movies here that I've brought in. Let me show you these awesome movies. All right, I have here, I'm trying to, I've got some girls and I'm trying to teach them about science fiction. I think science fiction is very important. I think science is very important. So, yeah, they like Hannah Montana, which is okay, but I'd like to show them real science. So I started looking for science fiction movies and I noticed this terrible thing, that in modern day science fiction movies, it's not about science anymore. There's magic and superstition and it's like fantasy novels. You notice the genre of science fiction has changed over the years. It used to be hardcore physics and now it's all magical, and we used to be that thick a book. And now it's that thick to read one book because there's too many characters and they're all having magical experiences. And I hate magic and stuff like that. So let's not start talking about Harry Potter. So I just like science. So I thought I'll show them some real hardcore science fiction. So I got The Invaders from Mars, The Invisible Man, Plan 9 from Outer Space, Them. Has anyone seen the movie Them? It's about giant ants affected by a nuclear, not because of magic, but because of a power station leakage. And the ants walk around all the time just going, ee, 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 which is completely non-scary, but somehow very scary. It's called Them. Queen? Oh, Queen! There's nothing scarier than Queen. The Invasion of the Body Snatchers. Countess Dracula. There's an overlooked classic. Now, that's a weird thing, isn't it? Because science, when it started off, the very first science fiction, who knows, like the very first science fiction book I know of, I was going to say the very first science fiction, but I might have got it wrong. Well, no. Well, you think of Tempest or something. No, that's magic. No, we're not going that way. No, I was going to say the very first science fiction was Mary Shelley writing Frankenstein, which is essentially science and horror sort of combined. But I'm wondering, what about Jules Verne? Was he before Mary Shelley or after? He was before. Okay, yeah. Good old the French, they're first every time. It's H.G. Wells? He was there.
What time was he? I'm not sure.
I don't know when H.G. Wells was. He was at lots of different times because he had this machine. Yeah, that's right. That's right. So anyway, very early on, science fiction started to degenerate into horror and themes of horror and things like that. So I thought I'd show them some horror films. The Day of the Triffids, The Day the Earth Stood Still, the original version. I understand there is a new one. And I Married a Monster from Outer Space, just to give them some sort of advice. So these are the movies I wanted them to see. Now, I love movies and I have about a bazillion movies at home. And so I was hunting for the movies to show the girls and I knew which ones I wanted to show them. And I realised I was able to find them more easily because how do you think I had arranged my DVDs at home?
Oh, you didn't really arrange them.
Thermonuclearly? Alphabetically? Yeah, I arranged them in a known order. What's the advantage in me when I search through my magnificently vast DVD collection? Possibly not. What's the advantage of me having my DVDs in order? Yeah, why? Why though? Why? We're not going to be doing superstition in this course. We're going to be doing science. We're going to need to know reasons for things and evidence and facts. Why is it faster to find it if I've got everything sorted?
Associate them with an index or something, like a letter or something.
Yes?
You can,
So why is that faster though?
because you don't have to keep searching through every single DVD. You just need to say, oh, okay, my DVD starts with the letter Z, so I just go all the way down.
So I can quickly have a rough idea about where to start looking, rather than say if I had a list, starting at the beginning, scanning along, I can think Z, it's probably near the end of the bookshelf, rather than the beginning sort of thing. That's right. So I thought we could do some algorithms on these, and I wonder, I've actually mucked up the ordering. I wonder if, can I have a volunteer, please? Someone who's really, really keen to dob in the person sitting next to them. Put up your hand if you'd like the person next to you to sort these DVDs into order for me. Thank you very much. And who's the person next to you? Oh, I know you, don't I?
I did 1917 with you.
Yeah.
But I had a motorbike accident.
I can't remember your name.
Dylan?
Dylan. Hello, Dylan. Welcome back. It's nice to see you. Were you nominating you or the poor person sitting next to you? Do you know this person? This is the attitude I like to see. He's not afraid. He's fearlessly going on and dobbing in a complete stranger. You'll never sit next to him again, will you? So, Dylan, I actually did trick you. Would you mind coming up here? And sorting them into order, because I just mucked up the order then. Somehow just sort them into order. Now, I want to tell you about the way I sort. Yeah, you've spotted the problem. It's tradition in English that if any string begins with the, we subtract that, which means them, for example, we're going to classify under M. Okay, if you could do that. If you could just put them in order, that'd be cool. Now, I'm going to show you something neat that we can do with things when they're sorted, and I thought, why not do it on DVDs? But we're just all going to wait a little bit.
What about if there's two the's?
What if there's two the's? No, it's only the first the. The algorithm is if the string begins with THE, remove THE, and then continue. So if the band was the, as a band was once upon a time to try and destroy indexing systems around the world, we would classify it under the. It's weird because a lot of them start with I, isn't it? I never realised most science fiction. Yeah, no, leave the I in there. But most science fiction movies seem to start with I. Space. Yeah, ignore spaces. Let's suppose we're compressing our strings, and if it starts with a semicolon, we'll ignore all we'll just look at alphabetic characters, and we'll assume everything's uppercase, and we'll remove the first three letters if they're THE. A PlayStation game that's Sing Star Queen, that would go under S. Yeah. Yep, it's going very slowly, but you're doing very, no, it's absolutely fine. Yep. Awesomely good. Thank you very much. Absolutely perfect. Oh, okay. Well done. Now, I need 10 volunteers. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that okay? Okay. Can you guys come down here and stand out the front? Thank you very much. It was Dylan? Yeah. Thanks, Dylan. That's awesome. Oh, well done. That's very good. Come and stand here. Line up along in front of the board. I need this bag. It's very important. Now, what I'm going to do is I'm going to give each of you... Oh. Dylan, can I ask you to help me a bit? So what we're going to do is, Dylan is going to give each of you the DVDs. Just give it to them in the right order, if you can. Sorry. And I'd like you to mark your DVD with a number, just because it's going to be hard for everyone to see the letters from so far away to see when they're ordered. So I've got some cards here with numbers on, so you'll be the lowest one. 1, 2... If you just put it in, if you can put it in order, yeah, so give him the lowest alphabetically ordered one. And if you could just insert that in the bottom, so it's, that's brilliant. If you put it all the way up, it's actually quite hard to get out. But, I know you too. What's your name? Cliff. Hello, Cliff. I've forgotten your surname. Very nice to see you again. Hello, there you go. There you go. I don't recognise you at all. Thank you. Thank you. Oh. Oh, thank you. Okay. Now, I'll just move this interrogator out of the way. Oh, well, here, we'll see if we can trap him. There we go. Right, there we go. Thank you, Dylan. All right, so what have we got? We've got Countess Dracula. We have The Day of the Triffids. We have The Day the Earth Stood Still, the original version, which is very good. I Married a Monster from Outer Space, Invaders from Mars, Invasion of the Body Snatchers, The Invisible Man. See, all these eyes. Plan 9 from Outer Space, them, and Queen Singstar. Thank you. Thank you very much. Can we give... Because that was fantastic. Now, can you just hold them up so everyone can see the number when it's in there? Oh, thanks. Can you slip it inside? Because we might be moving the disc around and we want it to sort of attach. Yeah, so if you could slip it somehow sort of between the plastic and the cover. Yeah, awesome. Thank you. Now, I don't know if you were watching while Dylan was doing that, but I was watching him and he did different things both times. 2 times you had to sort it, but I noticed you did different things both times. What did you do the first time? Do you remember how you sorted it? Was everyone watching what he was doing? It was very interesting. What did you do?
I was trying to say the alphabet.
You were saying the alphabet, but how did you arrange them? Yeah, I'm not articulating it very well, and I'm picking on you now for a 3rd time, I'm sorry. So let's say your name's Dylan. I'm going to ask you. We have a problem. What's the problem? We lost the firewire cable, but what's the problem in this situation? We need to sort the numbers. Okay. So that's the problem, sorting the DVDs. The algorithm is the what? How's an algorithm different to a program?
It's just what the steps that it needs to do.
The steps it needs to do, independent of any language or particular realization or use of memory or anything like that. What's that?
The first time I pick the DVD.
Hang on, I'm going to hold the microphone up so everyone can hear what you're saying. Because he's actually, his eyes lit up. You've just remembered what you did. Because often, all the time, when we do things, we just do them. And often we don't reflect on what we're doing. Your body does clever things and your brain does clever things, but often unless we take a step back and look at it, we don't notice what we're doing. So, yeah, tell us. Speak in the mic.
So the first time, I looked
Sorry,
at the first DVD.
sorry to be a pain.
Okay, yeah.
I can't hear that. Can anyone hear that?
Hello?
No, that was just a... Oh, yeah. I think the mic's just turned way down. Go.
Okay, so the first time, I looked at the first DVD I had.
Yep.
And I tried to put it into the order.
Yep. So you got the first DVD from the pile, from the unsorted pile?
And then try to make an order. But
Yep.
when I was walking along, I'd look for the...
Yes. Yes. Thank you very much. That's exactly what you did. Thank you. Well done. What he did the first time was he pulled the DVDs out of the unsorted pile one at a time. And he placed them into a sorted pile. And as he took each new one out, he inserted it into the right spot in the sorted pile. Does anyone know what that algorithm is called? No. Insertion sort. Insertion sort is, we start with unsorted data, we go through the unsorted data one element at a time, and we put it into the correct spot so far, ignoring the remaining unsorted data. So when you've only got one thing, there's only one right spot for it. It's at the beginning. Then you pick the next thing up. Now you've got 2 things, so you make a decision. Does this go before that one or after that one? You make a decision by comparing them, put it down, then you pick up the 3rd one. And you think, oh, where can I put that? How many spots have you got to put the 3rd one? 3 spots. So you do a couple of comparisons. Best case, how many comparisons do you have to do? 1 comparison. The first comparison tells you it goes right at the end. Or you might do another comparison. 2 comparisons get you to there. Or a 3rd comparison. Do you need to do a 3rd comparison? No, the 2nd comparison tells you where it goes. Okay. That's called insertion sort. It's a beautiful sort. It's actually what I do whenever I'm playing cards without even thinking about it. As I pick up my cards and insert them into my hand, I'm always doing insertion sort if anyone plays cards. But the second time, describe again what you did the second time.
I tried to find the next letter.
Yes.
I looked along and tried to find.
Okay, so he came to the first position. What's your name?
Shogun.
Shogun. That's an excellent name. Well done. He came to Shogun and he said, instead of giving you one and then picking the next one and working out if you guys have got to swap and things, he wanted to put the first one in the exactly correct spot first time through. So he wouldn't ever have to go back to it again. So he gave it to you and he moved on and he never came back to you again and never did any more comparisons. He did all the comparison in his head first and gave you the right one. Then he took the next smallest one and gave it. Then he took the next smallest one and so on. Who knows what that is called? Selection sort. That's not shell sort. That's not shell sort. But as punishment for Jara. Is it Jara? Punishment for Jara. Come down here, Jara. We're about to do a bubble sort. Jara, tell everyone the algorithm for bubble sort.
You go through, oh man.
No, don't even tell us. No, don't, just stand here. We will do it. No, we'll do it. That's how we'll say it.
Until you can't swap it anymore, and then you go to the next one, and then you keep swapping it off until you can't swap it.
Yes, it's a series of swaps.
Yeah.
All right, can you guys just move into a different order? You can't look there. Oh, actually, no, just pass the DVDs. Stay in the same order. Just jumble your DVDs around a bit. Yeah, I'll take that one. Thanks. Let's get this one here. That's really good. All right. There you go. That's really good. All right, good. You've got 2. Yeah, well done. Okay. This is what we call the sorting hat. So I'm going to put that on you. Now, can you see anything, Jarrah?
I can see perfectly.
No, he can actually see. Yes, spin him around. Okay, now I want you to ask 2 people. Your name is person 1, your name is person 2, your name is person 3, 4, 5, 6, 7, 8, 9, 10. They're not your names, they're your indexes. Does everyone remember their index? All right, ask some people by index number to compare their cards, and we're going to carry out a bubble sort. Do you mind standing there with a hat on? It's okay. You don't look silly. There's a mic. You don't actually. Take there, Jarrah. I've got a mic. Hold it up. No. There you go. Have you got it? That's right. It's a tiny little one. If you hold that inside, just try and do it. The reason I've got him blindfolded is I want you to see an algorithm is something that's carried out completely mindlessly. As human beings, if we look at what we're doing, our brain makes little shortcuts and we just think, oh, I can skip that step because of that. But because Jarrah now has no notion of the data, he's oblivious to the way the data is actually sorted, he will give us a precise execution of the algorithm. All right, go.
What am I asking?
You can ask, say, for example, index 1, is your card bigger or smaller than index 3?
Do our indexes change as
No. You're always index 1, but
Is your card bigger or smaller than index 2? Smaller. Am I sorting in ascending?
don't mind. Might as well make it ascending.
Okay, good. All right.
Yep.
Index 2, is your card bigger or smaller than index 3?
No, it's not bigger.
Oh, I like it. Well done. That's very good. He didn't say, yeah, we can't say is it smaller or bigger, because if we say smaller or bigger, what else do we have to allow for? Equals. In this case, we've got data without repetition, so it's irrelevant. But computers can't do 3-way comparisons. So yeah, is it bigger? We can only ask yes/no questions. I'm sorry, I said.
Index 3, is your card bigger than index 4?
Yes.
Can you swap with index 4?
That's right, just swap. Well done. Excellent. Okay, go.
Index 2, are you bigger than index 3?
Oh, hang on, no, bubble sort.
Yeah?
So you've got to keep going. Keep going all the way to the end.
Yeah, but index, oh God, I'm lost now.
Oh, sorry, I'm being...
Index 3 might be bigger than index 2.
You,
Go all the way to the end and then start.
your dad said, can you pay, I'll give you $100 if you get my son to sit down on the floor with 200 people looking at him with a bag on his head. And just whenever he says something, say it's wrong. So, man, I owe you big time, Jarrah. But you're doing absolutely fine. But don't forget, bubble sort keeps going the whole way along.
I feel like I'm back in under grade. Right. Index 4, are you bigger than index 5?
Yes.
Yeah, can you swap?
Well done.
Index 5, you're bigger than index 6?
No.
Okay, good. Stay that way. Are you bigger than index 7? Yes. Alright, swap. Index 7, you're bigger than index 8?
No.
Okay, good. Index 8, you're bigger than index 9?
Yes.
Okay, swap. Index, how many other?
10.
9, 10, bigger? Alright, swap.
Well done. Okay. No. He's thinking hard. By the way, the prac exam is, can everyone bring a Woolworths bag? You're doing very well, Jarrah. Okay. Are you ready to keep going with the next round?
Okay, where was I? So I should start from 1 again?
No. You could.
Where was I? I think I was up to 3. I think 3, no.
It's a bubble sort. It's oblivious.
Alright, whatever. 1, you're still, are you bigger than 2? No. Good. 2, are you bigger than 3?
Yes.
Swap. 3, you bigger than 4?
Yes.
Swap. 4, you bigger than 5?
No.
Good. 5, you bigger than 6?
Yes.
Swap. 6, you bigger than 7? No. Good. 7, you bigger than 8?
Yes.
Swap. 8, you bigger than 9?
Yep.
Swap. 9, you bigger than 10?
Nope.
Good. 1, you bigger than 2? No. 2, you bigger than 3?
Oh, sorry. For the answer.
Go.
God, I hate names. Shit.
Yeah.
Swap. 3, you begin with 4.
No.
4, you begin with 5.
Yep.
Swap. 5, you begin with 6.
No.
6, you begin with 7.
Yep.
Swap. 7, you begin with 8.
Yep.
Swap. 8.
Oh, wait, hang on.
What?
Do you have to do any more comparisons now?
I don't remember.
Oh. Notice that as a result of the first pass through, Jarrah successfully put the biggest one in the end position. So he never has to do a comparison with the end one ever again.
He'll still be doing it anyway because he's not going to be able to figure it out.
No, no. You will always... Thank you. After the first pass through, you are guaranteed that the biggest one is now in the correct spot. But everyone else, who knows? They've all jumbled up a bit. After the second pass, which you did successfully, that's already in the right spot. So now on your third pass through, once you get to the third last position, you don't need to keep going. And I think we can do one more round and then maybe stop.
Why do you begin with 2?
Yes.
2. What? Swap.
That's-
When did you do that? 2, begin with 3.
No.
Alright, 3, begin with 4.
No.
4, begin with 5.
No.
5, begin with 6.
No.
6, begin with 7.
Yep.
Swap. 7, begin with 8.
No, you're done now.
Oh, right.
Okay.
Oh, yeah. I'm sorry.
Thank you. Can everyone give Jarrah a big hand? Now, Jarrah, look at the data. Look at the data. You've got it completely sorted now, except there's only one who's out of order, which is the data you're still the original version. Now, notice each pass from now on, that's just going to move down 1. Can you see that?
What did we do?
We did a bubble sort.
No, like.
Can you hear? Oh no! Oh, I had fly sprain here. It's supposed to have neurological effects. Can you hear? No. Thank you. Can everyone give Jarrah another hand? Sit down. Well done. Okay. Guys, just stay there 1 second. That was the most humiliating thing I've ever done to anyone before. So I'm very sorry. And you did that magnificently well. Notice now, it's still going to take us. Oh, I can hear something now. It's still going to take us a couple more passes because in each pass, this 4 is just going to move down 1. All the other numbers got into position quite quickly, except the 4. By the way, do you remember at the beginning when we jumbled up the numbers? Who had the 4?
Number 3.
No, who took the 4 and jumbled it up? I did. Everyone else jumbled locally with their neighbours. A bubble sort creates local order really quite quickly. I wanted to have one that's way out of whack, so I took 4 right up to the end. And that's going to take that many passes to get it down to this end. Now, thank you very much, everyone. Can we give them all a hand, because you did magnificently well. Thank you. Thanks. All right, we'll take a break now. I'll try and fix up this fire alarm, and we'll meet again in 10 minutes' time. Thank you very much. Thank you, everyone. Thanks.